Okay, earlier we learned how to solve the radical expression or radical function. Now we want to learn how to solve with exponents. Okay, so there's an art. Okay, first of all, some review. If a to the n equals to b, then you can write it as a equals to nth root of b. For example, if 2 to the cubic root equals to 8, then 2 is equals to cubic root of 8. Okay. So this works when n is an odd number. But for even roots, they have an even root property. If a to the m equals to b, then a equals to positive and negative square that m's root of b, where m is even number. So why is that? Why these have two answers, a positive and negative answer? This is because, take a look, if I give you an example, you understand. 3 squared equals to what? Equals to 9. So, but negative 3 squared also equals to 9. So that means what? When we solve a function, if I tell you that, hey, x squared equals to 9, you want to solve for x. So by these two equations, you know that x has two answers. X is either equals to positive 3 or x equals to negative 3. Oops. So remember, when we have even, because of this even root property, that's why when we try to raise the power to the even number, we need to check our solution, because sometimes the solution is not true. That's from the previous section. Okay, so let's take a look. X to the 4th equals to 16. Well, we need to use the even root property. So we know that the solution has a positive and negative solution. So we 4th root on both sides, and then we leave a positive and negative sign outside of the root. So I have what? X equals to positive or negative 2. Let's have another one. We have 2x at 4 squared equals to 13/6. Again, even index, we need to use our even root property, which means when you square root on both sides, you need to have a positive and negative solution. So I have what? 2x plus 4 squared. We square root on that. So I have a positive and negative square root of 36. So I have a 2x at 4 equals to positive and negative 6. Okay, you can write in separate. So you have a 2x plus 4 equals to 6, or 2x plus 4 equals to negative 6. And then you solve it separately. So you minus 4 on both sides. I have a 2x equals to 2. You divide by 2, so x equals to 1. In here, you subtract 4 on both sides. I have a 2x equals to negative 10. You divide by 2 on both sides, you have x equals to negative 5. So here is our solution. Let's do another one. So I have 6x minus 9 squared equals to 45. Now we use the even root property. We know that we're going to have a positive and negative solution. When we square root on both sides, on the left, we have 6x minus 9 equals to positive and negative square root of 45. Okay, how do I simplify square root of 45? It's equal to what? 45 square root of 45 equals to 45 equals square root of 5 times square root of 9, where square root of 9 is equal to 3 times square root of 5. So you will have positive and negative square root of 3 times square root of negative 5. Okay, so in this case, we don't need to, because that rational root, they can be simplified. We can just use equation. So we add 9 on both sides. I have 6x equals to 9, positive and negative 3 square root of 5 divided by 6. So x is equals to 9 plus or minus 3 times square root of 5 divided by 6. Because you can continue simplify this as an integer so that 9 plus or minus this is not going to be two different numbers like what we have in the previous example here. The reason we write separately because 6, you can continue to operate it by combining the terms. Okay, so next have another example. Now let's try something that without the square root. Let's try the even root. I have x plus 4 to the cube minus 6 equals to 119. What's your first step? You want to isolate it, the part with exponent, which means you want to add 6 on both sides. I have x plus 4 to the cube equals to 125. And then you cubic root on both sides. Since this is a even root, so that means we don't have a positive or negative. So I will have x plus 4 on the left side, and then cubic root of 125 on the right side. So cubic root of 125 is equals to 5. And then I subtract 4 on both sides, I have x equals to 1. So this would be the solution. Again, I have 6x plus 1 squared at 6 equals to 10. So what's the first step? You want to isolate the exponents. The exponent part. So I subtract 6 on both sides. I have 6x at 1 squared equals to 4. And then what? It's an even root property. So that our solution has a positive and negative sign. So I have a 6x plus 1 equals to positive or negative 2. And then we need to write it separately. 6x plus 1 equals to 2, or 6x plus 1 equals to negative 2. And then we subtract 1 on both sides. I have x, 6x equals to 1, and then divide by 6. I have x equals to 1/6. And then the other one is you subtract 1 on both sides. I have 6x equals to -3. You divide by 6. So I have x equals to 3/6. We simplify it. We have x equals to 1/2, -1/2. So the reason we're doing this, because these has different, they can be, the terms, they can be combined because they have a like term in here and here. So we need to separate them. Okay, so sometimes when we see a fraction in the exponent, we need to convert this to exponent first by using this. A to the m over n is equals to nth root of a to the n power. Or you can write it to nth root of a to the n power. Which way you want to do it first? Okay. So for example, I have 4x at 1 to the 2/5 degree equals to 9. So I can write it as what? 4x plus 5 fifth root to the second power equals to 9. Okay, how can I get rid of, we can get rid of one by one, right? So the first is I want to get rid of the square, the second power, by square root them both sides. But since by the even root property, we know that it's going to have two answers, positive and negative. So I square root both sides. I have the fifth root of 5x plus 1 equals to positive and negative square root of 3. Okay. So, not square root of 3, square root of 9, which is 3. Okay, so now I have fifth root. How can I get rid of fifth root? That's something that we just learned earlier. We raise to the fifth power, right? On both sides. So I have 5x plus 1 equals to positive or negative 3 to the fifth power. So, oh, a 4x. Why I write this 5x? Okay, so either 4x plus 1 equals to 125. Is that 125? No, 3 to the fifth is equals to 243. Or 4x plus 1 equals to negative 243. We subtract 1 on both sides. We have 4x equals 242. And then we divide by 2. Divide by 4 on both sides. So I have x either equals to 101 over 2. Or if we subtract them, we have 4x equals to negative 244. We divide by 4 on both sides. I have x equals to negative 61. Here's the true solution. Let's do another one. This fractional power. We have 3x minus 2 to 3/4 power equals to 64. Again, you want to write this as a radical expression. So I have a 3x minus 2 to the 4th root and then cubic power to 64. So in this one, it's not an odd number. We need to what? By the odd root property, we don't need to check the answer. We can just what? Cubic root on both sides. So I have fourth root of 3x minus 2 equals to cubic root of 64. So fourth root of 3x minus 2 is equals to, what numbers? 4. Okay, the cubic root of 64 is equals to 4. Okay, so what's next? So you have fourth root. You want to get rid of the fourth root. That means you need to raise up the power to the fourth power. Raise the power to the fourth power. Okay, but be careful. This is a what? Even index. So that means we still need to check our solution. Okay, so when we raise up, we have 3x minus 2 equals to 4 to the fourth power. Simplify, I have 3x minus 2 equals 256. I add 2 on both sides. I have 258. And then I divide by 3. I have x equals to 86. Again, we need to check our solution by substitute x equals to 81 into our equation. So I have square root, not square root, fourth root of 3 times 81 minus 2 to the third power. If this is equals to 64, okay. So 3 times 81 is equals to 258. Sorry, why is 243 or 56? Oh, this is 86. Sorry, 86. This is 3 times 86 is equals to 258. And now subtract 2 to the cubic power. If this is equals to 64. This is 256 to the fourth power to the third power. If this is equals to 64. Okay. Fourth root of 256 is equals to 4. So now we have 4 to the cubic power. Is this equals to 64? Yes, this is equals to 64. So that means x equals to 86 is our solution. Okay, that's it today. Today somehow I made lots of typo. I hope you didn't do it on the quizzes or the tests. So be careful when you do the operation. If you make some tiny mistake, you will lead to the whole solution wrong. Okay, thank you for coming today. I'll see you next week.